Good morning, all. Myself, Nageshwara Reddy, working as an assistant professor in Personality Engineering College, Hyderabad. Today, I am going to explain about tunnel diode. So, what is meant by tunnel diode? Tunnel diode is a heavily doped PN junction diode in which the electric current decreases as the voltage increases. So, tunnel diode is a heavily doped diode. The current decreases as the voltage increases. In tunnel diode, the electric current is caused by tunneling. The tunnel diode is used as very fast switching device in computers. It is also used in high frequency oscillators and amplifiers. The symbol of tunnel diode. The circuit symbol of tunnel diode is shown in below figure. In tunnel diode, the p-type semiconductor act as anode and the n-type semiconductor act as cathode. So, who invented the tunnel diode? Tunnel diode was invented in 1958 by Leo Esaki. Leo Esaki observed that if a semiconductor diode is heavily doped with impurities, it will exhibit negative resistance property. So, what is meant by negative resistance? Negative resistance means the current across the tunnel diode decreases when the voltage increases. So, what is meant by negative resistance property? Negative resistance means the current across the tunnel diode decreases when the voltage increases. In 1973, Leo Esaki received the Nobel Prize in Physics for discovering the electron tunneling effect used in these diodes. A tunnel diode is also known as Esaki diode. This is the another name of tunnel diode, which is named after Leo Esaki for his work on the tunneling effect. The operation of the tunnel diode depends on the quantum mechanics principle known as tunneling. So in electronics, tunneling means a direct flow of electrons across the small depletion region from n-side conduction band to p-side valency band. So what is meant by tunneling? Tunneling means direct flow of electrons across the small depletion region from n-side conduction band into p-side valency band. So this is the diagram of the tunnel diode. So p-type semiconductor, n-type semiconductor. So the width of the depletion region is very small in tunnel diode, whereas in case of normal p-n junction diodes, so the width of the depletion region is more. So the tunnel diode, so the germanium material is commonly used to make the tunnel diodes. So how we can prepare the tunnel diodes? By using the germanium materials. They are also made from the other types of materials such as gallium arsenide and gallium antimonide and silicon. So width of the depletion region in tunnel diode. So the depletion region is a region in a PN junction diode where mobile charge carriers, free electrons and holes are absent. Depletion region acts like a barrier that opposes the flow of electrons from the n-type semiconductor and holes from the p-type semiconductor. So what is the width of the depletion region in case of tunnel diode? The width of the depletion region depends on the number of impurities added. So impurities are the atoms introduced into the p-type and n-type semiconductor to increase the electrical current, to increase the electrical conductivity. If a small number of impurities are added to the PN junction diode, a wide depletion region is formed. On the other hand, if a large number of impurities are added to the PN junction diode, a normal depletion region is a narrow depletion region is formed. So in ordinary PN junction diodes, so a wide depletion region is formed, whereas in case of the tunnel diodes, narrow depletion region is formed because of heavy doping. This is the forward bias tunnel diode. So in tunnel diodes, the p-type and n-type semiconductor is heavily doped, which means a large number of impurities are introduced into the p-type and n-type semiconductor. This heavy doping process produces an extremely narrow depletion regions. So because of heavy doping, extremely narrow depletion region is formed. The concentration of impurities in tunnel diode is 1,000 times greater than the normal PN junction diodes. So unlike the normal PN junction diode, the width of the depletion layer in tunnel diode is extremely narrow. So even so, applying a small voltage is enough to produce the electric current in tunnel diode. So only small voltage is enough to produce the electric current in tunnel diodes. Tunnel diodes are capable of tunnel diodes are capable of remaining stable for a long duration of time than ordinary PN junction diodes. They are also capable of high speed operations. So what is the difference between the normal PN junction diodes and the tunnel diodes? They are capable of remaining stable for a long duration of time. So they are very stable when compared with the ordinary PN junction diodes. So they are also used in high speed operations. So concept of tunneling. So what is the concept of tunneling? The depletion region or depletion layer in a PN junction diode is made up of positive ions and negative ions. Because of these positive and negative ions, there exists a built-in potential or electric field in the depletion region. This electric field in the depletion region exerts electric force in a direction opposite to that of the electric field. So another thing we need to remember is that the valency band and conduction band energy levels in the n-type semiconductor are slightly lower than the valency band and conduction band energy levels in the p-type semiconductors. This difference in energy levels is due to the difference in the energy levels of dopant atoms used to form the n-type and p-type semiconductor. So how the electric current flowing in the tunnel diodes? In tunnel diode, the valence band and conduction band energy levels in the n-type semiconductor are lower than the valency band and conduction band energy levels in the p-type semiconductors. So the valence band and conduction band energy levels in the n-type semiconductor slightly less than the valence band and conduction band energy levels of p-type semiconductors. So in normal PN junction diodes, the difference in energy levels is very high. Unlike the ordinary PN junction diode, the difference in energy levels is very high in tunnel diode. This difference in energy levels is very high in tunnel diodes, and normal diodes that is very less. Because of this high difference in energy levels, the conduction band of the n-type material overlaps with the valence band of p-type material. Quantum mechanics says that the electrons will directly penetrate through the depletion layer or barrier if the depletion width is very small. So the depletion layer of tunnel diode is very small. It is in nanometers. So the electrons can directly tunnel or penetrate across the small depletion region from n-side conduction band into p-side valence band. So in ordinary diodes, current is produced when the applied voltage is greater than the built-in voltage of depletion region. But in case of tunnel diodes, a small voltage which is less than the built-in voltage of depletion region is enough to produce the electric current. So you can observe how the electric current flows in the tunnel diodes. In tunnel diodes, the electrons need not overcome the opposing force from the depletion layer to produce the electric current. The electrons can directly tunnel from the conduction band of n-type region into the valence band of p-type region. Thus, electric current is produced in the tunnel diode. So how tunnel diode works. So unbiased tunnel diode. So when unbiased means uh, unbiased means there is no proper supply. There is no applying. There is no applying proper voltage to the device. So what is mean by biasing? Biasing is nothing but the process of applying proper voltage and the process of applying proper voltage to the device. So unbiased tunnel diode. So when no voltage is applied to the tunnel diode, it is said to be an unbiased tunnel diode. In tunnel diode, the conduction band of the N-type material overlaps with the valency band of P-type material because of heavy doping. Because of this overlapping, the conduction band electrons at N side and valence band holes at P sides are nearly the same energy levels. So when the temperature increases, some electrons tunnel from the conduction band of N region to the valence band of P region. In a similar way, holes tunnel from the valence band of P region to the conduction band of N region. So the net current flow will be zero because an equal number of charge carriers flow in the opposite directions. So in case of unbiased tunnel diodes, the net current flow is zero. So you can observe in the graph, there is no current flowing whenever the tunnel diode is unbiased. So whenever a small voltage is applied to the tunnel diode, what happens? So when a small voltage is applied to the tunnel diode, which is less than the built-in voltage of the depletion layer, no forward current flows through the junction. So, however, a small number of electrons in the conduction band of N region will tunnel to the empty state of valence band in P region. This will create a small forward bias tunnel current. You can observe in the graph that is on the x-axis voltage and the y-axis current. So, a small number of electrons in the conduction band of N region will tunnel to the empty states of valence band in P region. This will create a small forward bias tunnel current. The tunnel current starts flowing with a small application of voltage. So whenever the small voltage is applied to the tunnel diodes, only few number of electrons are flowing from conduction band of N region to valence band of P region. That's why only small current is flowing in the whenever the small voltage is applied. So whenever the applied voltage is slightly increased, when the applied voltage of the tunnel diode is slightly increased, a large number of free electrons at N side and holes at P sides are generated. Because of the increase in voltage, the overlapping of conduction band and valency band increases. In simple words, the energy level of an N-side conduction band becomes exactly equals to the energy level of a P-side valency band. As a result, maximum tunnel current flows. So you can observe in the graph, the energy level of N-side conduction band becomes exactly equal to the energy level of P-side valency band. Maximum tunnel current flows. So in fourth step, as the applied voltage is further increased. If the applied voltage is further increased, a slight misalignment of the conduction band and valency band take place. So since the conduction band of N-type material and the valence band of P-type material still overlap, the electrons tunnel from the conduction band of N region to the valence band of P region and cause a small current flow. Thus, tunneling current starts decreasing. So whenever the current is further increasing, or a tunneling current starts decreasing. So whenever the applied voltage is largely increased, if the applied voltage is largely increased, the tunneling current drops to zero. At this point, the conduction band and valency band no longer overlap and the tunnel diode operates in the same manner as the normal PN junction diode whenever the applied voltage is increased. You can observe in the graph zero tunnel current. Whenever the zero tunnel current, maximum forward current. Whenever the voltage is slightly increased, so there is a zero tunnel current. You can, if this applied voltage is greater than the built-in potential of the depletion region, the regular forward current starts flowing through the tunnel diodes. The portion of the curve in which the current decreases as the voltage increases is the negative resistance region. So what is the negative resistance region? So the portion of the curve in which the current starts decreasing as the voltage increase is the negative resistance region of the tunnel diode. The negative resistance region is the most important and most widely used characteristics of the tunnel diode. A tunnel diode operating the negative resistance region can be used as amplifier or oscillator. So what are the applications of, what are the advantages and disadvantages and the applications of tunnel diodes? So see, advantages of tunnel diode: long life, high speed operation, low noise, low power consumption. So long life, high speed operations are fast, high speed switching circuits, low noise, they produce the low noise, low power consumption, they require only low power. So that is disadvantage of tunnel diodes. Tunnel diodes cannot be fabricated in large numbers. Only few tunnel diodes can be fabricated. Only few tunnel diodes can be fabricated in large numbers. Being a two-terminal device, the input and output are not isolated from one another. So applications of tunnel diodes. Tunnel diodes are used as logic memory storage devices. Tunnel diodes are used in relaxation oscillator circuits. Tunnel diode is used as ultra high speed switching circuits. Tunnel diodes are used in FM receivers. So thank you.